Today we're going to be covering blend modes in WebGL and Three.js, understanding how and why they work, and as an added bonus I'm going to show you a much more advanced way to do blending. So since we're covering blend modes, we won't be doing as much code as normal. Now, if you already know everything there is to know about this topic, feel free to skip ahead to whatever time it is I fill in here, if you just came here for the additive alpha explanation. First off, I've got a little simple project setup going here. As you can see, there's not much to it, mostly just the same basic setup we used to create a 3D basic world tutorial. This is intentionally pretty simple. Over here, I've got some quads that I'm going to render onto the screen, and these lines here change the blend mode so that we can see the effects of different blend modes. Running it just shows a quad along with some info on the side. The whole point of this thing is that we'll be able to observe how changes to the blend mode affect the overall image. Here, I'll go flip the blend mode. So if I change this line here to additive and rerun this, you can see that the images change, and we've got this one that's blending over top the other using this additive blend mode. And we can swap this for other blend modes, and the result shows up in the project. Let's take a step back now and understand what exactly is going on here, how WebGL and Three.js blend one image onto another, how that's controlled essentially. Let's start with some terminology. You've got the destination, or as it's often shortened to, DST, which is what's already on the screen in essence. Then you've got the source, or SRC, and that's the image you're compositing onto the destination. And all this is controlled by a couple functions that you can use to change how things are blended onto the screen, how the source and the destination are blended together. The first step is the blend function. Now in WebGL, this is called gl.blendFunc. In Three.js, you would supply values for the blend source and blend dest parameters on a material. And these, in essence, supply multipliers for the source and destination colors, respectively. And there's a bunch of constants here that can be supplied. You can look over the list here. Let's step through a quick example. Let's say that you supply the multipliers 1 and 0. So that means that for every pixel on the screen, the final color is equal to the source times 1 plus the destination times 0, which of course is just the source. If I change the values here on this line and we run it, you can see that the image completely overwrites the background. Let's try some other multipliers. So let's go with 1, 1. So in this case, that means that the color for every pixel on the screen is a straight up addition of the old color plus the new color. So the final color is equal to source times 1 plus destination times 1. Let's go and change this to 1, 1 in the code. And now that we run it, you can see that our image gets blended over top, making the background brighter. And one thing to note here is that remember that the edges of the image were black, and black is basically zeros. So when you add 0 to the background color, nothing happens. So this only brightens up in the middle. Now, the second part of what controls blending is the blendEquation. And up until now, our examples have always added the first and second parts together. i.e., it's always been source times source factor plus destination times a destination factor. WebGL, and thus Three.js, also define ways to modify the equation itself. In WebGL, this is gl.blendEquation, and in Three.js, these are the predefined blending equations. What this allows you to do is change how source and destination are combined. So instead of addition, if we want to change this to subtraction, the previous example changes as well. So let's step through. We'll use 1, 1 again as our blending factors, but we'll use subtraction as our blending equation. The final color for every pixel on the screen would thus become source times 1 minus destination times 1. We can go into the code and change this to subtraction, and when we run it, it looks a lot different than the additive version. Notice the color changes as you go towards the center, where previously it got lighter. It might seem that there's like a million options here, and there are. But a lot of effects mostly boil down to two modes, additive and alpha blending. Additive blending is that glowy, fiery look that you get, and we actually already covered it. It's the source times 1 plus destination times 1 example that we ran through earlier. And alpha blending isn't conceptually that hard either. It's source times source alpha plus destination times 1 minus source alpha. which you may notice is just a straight up linear interpolation between the two colors based on the alpha value. Now, if I use a texture with alpha and change the code here to use alpha blending, you get something that's composited over top of the background instead of brightening it up. Now let's talk about why having a separate additive and alpha kind of sucks. This is a neat trick that I actually discovered when I was working on an Xbox 360/PlayStation 3 title back when I first started working. First off, let's look at the problem it's solving. Let's say that I have a raging fire going on. Now, fire also should have a bunch of black smoke and ash coming out, so let's add some smoke coming out the top. If you have separate additive and alpha blending modes, then this has to be done as two separate particle systems, meaning as we move the camera around, one of them has to draw in front of the other. Either the smoke gets drawn first or the fire does, or they might even pop from front to back depending on the camera angle. Either way, it's not going to look great. Contrast that to if I combine this all into a single blend mode, which means that it's all a single particle system. Look at what happens as I move the camera around. It's all seamless, way better looking. To understand how it's done, we need to go back to the blend factors for both additive and alpha blending. So additive blending looks like this, 1, 1. Or it can also be source alpha 1, where you just want to have an option to control the overall fade with something other than just the color. And alpha blending looks like source alpha and 1 minus source alpha. So in additive, the final color is equal to source times source alpha plus destination times 1. And in alpha blending, the final color is equal to source times source alpha plus destination times 1 minus source alpha. And we need these to be the same equation somehow. You can do it like this. Our new additive alpha combination equation is going to be source times 1 plus destination times 1 minus source alpha. And we're going to have to write ourselves a special shader. So this shader, it needs to do two things. It needs to do the alpha blending itself. So here in the fragment shader, we multiply the final color by the alpha. By doing that, the blend mode we specified works exactly the same as alpha blending. See, source times 1 plus destination times 1 minus source alpha. Since we're manually multiplying the final color by source alpha ourselves, this is exactly the same as alpha blending. Watch, I'll change the blend mode here in our example program, and this works just like alpha blending. Next, for this to do additive blending, we need the 1 minus source alpha part to be equal to 1. That's easy. We need the source alpha to be 0, so that means that 1 minus 0 is equal to 1. And we can do that by having a special blend mode value in the shader that gets passed down per particle. And we simply multiply the alpha value by that. So if the blend value is 1, the shader outputs a normal alpha value. And if the blend value is 0, the alpha value turns into 0, and this whole thing becomes additive. And that's it. Once you do those two small tweaks, you have a combined blend mode that does both. And your particle system takes a giant leap forward in both simplicity and in looks. Hope you enjoyed this. Make sure to like and subscribe as always. Leave a comment and especially let me know if there's a subject you want covered and I'll add it to my to-do list. Source code is up on GitHub, blah, blah, blah. Do whatever you want with it. Just don't ask me to support it. I'll see you next time. Cheers.